Hi, Chris Kuzmo here. Today we're going to talk about one of the classic limit problems, which is finding sine of x over x approaches as x approaches 0. And the answer is that the sine of x over x approaches 1 as x approaches 0. Personally, the way I think of this is that sine of x is approximately x when x is near 0. That's what virtually any engineer thinks. But let's turn to the mathematics, but we're not going to address this in the way you normally do, which you create a couple of triangles and a pi wedge, and you show that their sizes, that one is larger than the other, is larger than the third, and that therefore, since the largest one and the smallest one approach the same size, then the one between the two approaches the same size as well, and that's using the squeeze theorem. But a key step in showing this is to demonstrate that the sine of x is less than x for small x. And so you can do that by using triangles and pi wedges. But let's do this strictly using a trigonometric identity. So let's consider the idea that if some function c of x is less than 1, and we define a function f of x as 2 times f of x times c of x over 2. So f of x is defined in terms of itself, twice itself at half the value. That's the behavior of x. X equals 2 times x over 2. So if f of x was x, then c here would need to be 1. C of any value would need to be 1. But if it's the case that c of x is less than 1, then clearly f of x should be less than x for small x, because this c is pulling down f. All right. The cool thing is that this definition on the left precisely matches the trigonometric identity of the sine of x equals 2 times the sine of x over 2 times the cosine of x over 2, because, first of all, the 2 sine of x over 2 matches the 2 f of x over 2. And then this function cosine x over 2, well, guess what? The cosine of, well, anything is less than 1. So this is not a rigorous proof that sine of x over x approaches 1 as x approaches 0. But it illustrates the key concept of this relationship between the sine of x and x without relying on any geometric interpretation. It's just directly using a trigonometric identity. So there you go.